Hello friends, welcome to engineering tutorial. So in the previous video we discussed the basic concept of a linear DC machine. We discussed its working principle, the various mathematical equations and the principles associated with it. So now we are going to start our discussion with the DC machines. So the first series of videos, it will be related to DC generator. So before going into DC generator in detail, first we must understand its the fundamental principle, the basic principle, and for that we have to take the case of a simple loop generator. Now once we understand how this thing works, the simple loop generator, then we can go into the DC generator part. Okay, so let's first go into some basic introductory parts which we have already covered, for just to have a to refresh a few things. The electrical machines, as we all know, it can be classified into two categories: DC machines, direct current, and alternating current, okay, AC machines. Now majority of the electrical machines which are in operation or in application, they are AC type, okay. But still the DC, it is very important to understand, to study the DC machines, only then we can go to the AC part, okay. Even though they are not that used, majority is of AC machines, still we have to study it. Now one of the main advantages offered by the DC machines, be it a motor or a generator, is the speed control characteristic, okay. So good speed control is shown by the DC machines, okay. Mostly when we say DC machine, we will see that DC motors are much more common as compared to DC generators, okay. So the one main advantage which is offered by DC machines is that of the speed characteristics, speed control characteristics. Now the generator principle, the basic definition of an electric generator is that it is a machine which converts mechanical energy into electrical energy, okay. Rotatory motion is converted into voltage or current form, okay. So that is the basic underlying principle: mechanical to electrical output, mechanical input to electrical output. So the principle is it obeys Faraday's and Fleming's rule. So we have already covered these things in the previous videos, so I would recommend you to please watch those videos first. I am not going into detail about these things again. So the basic principle is that when a moving conductor rotating in a magnetic field, it cuts the magnetic flux lines and EMF is induced in it. So it obeys both Faraday's and Fleming's rule. So as per Faraday's law, the EMF which is induced because of the conductor cutting the flux, the rate of change of flux, is n d phi by dt, where the loop which the conductor loop, number of turns of that conductor is given by capital N. E is the EMF induced and phi is the magnetic flux. D phi by dt is the rate of change of flux with respect to time. And as per the Fleming's rule, it states that when a conductor moves in a magnetic field in a particular direction, and the direction of the magnetic flux is perpendicular to the direction of motion, then the current is induced in a direction which is perpendicular to both the direction of force or motion and the direction of magnetic flux line. So in three mutually perpendicular directions, the movement, the flux line and the direction of the induced current, they are in three mutually perpendicular directions with 90-degree angles with respect to each other. So you can imagine the x, y and z axis, okay, to understand that. So we have already covered this. So now coming to the generator. Now the essential components of a generator or any DC or any machine, electrical machine, is magnetic field, okay, conductor or group of conductors that are placed in the magnetic field, and the movement of the conductor, the motion of the conductor or group of conductors in the magnetic field. These are the three key aspects of a machine, electrical machine. So a basic simple loop generator, it looks something like this. The magnetic field is produced by the magnet, the north and south pole pieces. We have a simple coil, a one turn coil, a single turn coil, which looks something like a parallelogram or rectangular because it is the side view. Actually we have taken a rectangular coil with coil sides AB and CD. Now just don't pay attention to this direction of current, we'll get to that. Just focus on the coil. Now the magnetic field, the flux lines, it looks something like this from north to south, the flux lines, the magnetic field, and this is the rectangular coil or one turn coil because there is only one round, one turn, not multiple turns. The coil sides AB and CD. Okay, so the basis of generator is a moving conductor in a magnetic field. So obviously this coil will rotate in this magnetic field to get us some electrical output, to get the induced voltage. For example, for now this case, let us assume that this here it will rotate in clockwise directions, okay. This coil, it rotates in clockwise direction. We will examine the electrical output for the various positions. These are the positions 1, 2, 3, 4, 5, 6, 7, 8. We will examine in each of these positions what will be the induced voltage, what will be the electrical output, because it is a generator. Mechanical motion, rotatory motion will be converted into electrical output. So the loop coil in various positions. Now when the loop is in position 1, it means the coil side AB, okay, the sides of the coil, let us say the coil side AB is in position 1, it touches this point in this position. In that case, the flux lines, they are not cut by the coil sides, okay. Please listen to me carefully here. When the coil side AB, this side is in position number 1, okay, this you can approximate it something like this. Here the flux lines, the magnetic flux lines, they are not cutting, the coil sides are not cutting the flux lines, they are actually in parallel directions. In that case, the induced EMF will be 0 because the rate of change of flux with respect to time is 0, because the flux lines are not cut by the coil sides AB or CD. See, AB and CD, the flux lines are actually parallel to them, it is not cutting them. So the induced EMF will be 0. Now the same thing will happen when it is in position number 5. See, 1 and 5, they are actually opposite, they are facing each other. So the same thing will happen at position number 5. As position number 5 also, the coil sides, they are not cutting the flux lines, but they are actually running parallel, coil sides AB and CD. Now when the coil side AB the coil side AB is in position number 2, here the coil side AB is at position number 2. So in this position, okay, in this position, the flux lines, they will be cutting the coil sides at a particular angle, okay. The flux lines, they will be cutting them at a particular angle. Now this is a 2D diagram, so it will be very difficult for you to actually visualize the whole thing. So in this case or this case, when they are at position number 2, see here, they will be cutting the flux lines at a particular angle. They are not parallel. So when this coil is tilted, imagine this coil slightly tilted towards 2. The coil side AB is touching point number 2. So it will look something like this. This is for the coil side AB. This diagram is for coil side AB touching position number 8 and CD touching 4. So you can imagine it like that. It is tilted, the coil is tilted. So the flux lines, they are cutting the coil sides at a particular angle. So here some EMF will be induced, okay, some EMF will be induced. The magnitude of that EMF will be low, it will be less. So the same thing will happen at position number 4, 6 and 8, when the coil sides are tilted at a particular angle with respect to the flux lines. But the thing is that when the coil side will reach, means the coil side AB will reach 6 and 8, positions number 6 and 8, the direction of the EMF will be opposite. The magnitude will stay the same, but it will acquire a negative sign because the coil sides have changed. The coil sides have changed. Here AB is at the north pole side, CD is at the south pole side. When it rotates, AB goes to south pole side, CD goes to north pole side. It means when at positions number 2, 4, 6, 8, the magnitude of the EMF will stay the same. Please pay attention here. At positions number 2, 4, 6, 8, the magnitude of the EMF will be same, but for 2 and 4, positions number 2 and 4, the EMF will be positive. For positions number 6 and 8, the EMF induced will be negative, okay. So this is the EMF variation. At start, in position number 1, the EMF induced is 0. Pay attention, at 2, 4, 6, 8, the magnitude of the EMF is same magnitude, but for positions number 2 and 4, they are positive, in the positive direction. For 6 and 8, it is in the negative direction. Why? Because at all these positions, 2, 4, 6, 8, the coil is at a particular angle with respect to the flux lines. It is tilted at a particular angle with respect to the flux lines, and also these 2, 4, 6, 8, 2 is opposite to 6, 4 is opposite to 8. So obviously they will have same magnitude but opposite direction. These 2 and 6, the same magnitude, they will have same magnitude but opposite directions. 4 and 8, they will have same magnitude but opposite directions. Same thing happened for 1 and 5, but For 1 and 5 it is 0, so negative of 0 is 0, so it makes no difference. Now, when coil side AB reaches 3, it is rotating in clockwise direction when coil side AB reaches 3. Okay, when coil side it reaches 3. Now, the flux lines, they are actually perpendicular to the coil side. Okay, they are actually perpendicular to the coil side. So in this case, the maximum EMF is induced because the rate of change of flux is maximum. Okay, when the coil side AB is perpendicular to the flux lines at position number 3, when AB reaches this position 3, flux lines are perpendicular to the coil sides. Okay, you can visualize it something like this. Okay, here AB is in this side, but the same thing, the flux lines are actually cutting them at 90-degree angles. So in this case, just imagine AB is in this side, CD here is this side. In that case, the flux lines will cut the coil sides AB and CD at right angles. So maximum rate of change of flux and maximum EMF will be produced. Same thing happens when it is at position 7. Why? Because 3 and 7, they are opposite to each other. So whatever magnitude is at 3, same magnitude will be at 7, but opposite direction, negative sign. So here the EMF variation, you can see at 3 maximum EMF in the positive direction, at 7 maximum EMF in the negative direction, same magnitude, opposite direction. Why this polarity, this negative thing happens? Because as the coil rotates, the coil sides are changed from north to south pole. So because of that it happens. So always pay attention here. At position number 1, the coil sides are parallel to the flux lines, they are not cutting them, so it is 0. 1 and 5, 1 and 5, they are in pairs, same thing, 0, 0. 2, when it is at 2, it is the coil sides are cutting at a particular angle. Okay, so a small EMF is induced. 2 and 6, they are pairs. In 6, same thing happens, same magnitude but opposite direction. At 3, okay, at 3, the coil sides are at right angles to the flux lines. So maximum EMF is induced in the positive direction. Same thing at 7, they are in pairs, 3 and 7, same magnitude, opposite direction. Then at 4, again at an angle, the coil sides are at an angle, a particular low EMF will be induced. Same thing will happen at 8, but the magnitude of EMF will be the same, opposite sign. So 1, 5, 2, 6, 3, 7, 4, 8, they are pairs, same magnitude, opposite direction. Now, this is the direction of current flow in the coil. Okay, in this direction, see the arrows, the arrowheads. So the same direction will always be maintained, be it the AB side is here or the CD side here, the direction of flow of current will stay the same. See, when the coil side AB is towards north pole and CD is towards south pole, this is the direction of flow of current through the coil. See, here from B to A to D, D to C, then through the load, here a load is connected and we get an output voltage. Again here it is entering through here, again B to A to D, D to C. Okay, so this closed path, through this closed path, the current flow is in this direction. Now, when the coil side AB moves to south pole side and CD goes to north pole side, see, now Pay attention, the coils are sides, they are twisted here. See, they are twisted. So, the same, I said the direction of current flow will stay the same no matter in which coil side is here. When a coil side is towards the north pole, the direction of flow of current will be this, the same pattern. See, this is the main concept. Even though the coil side AB is here, the direction of coil current flow will be here, okay, upwards. So here when CD is here, coil side CD is here, same, the current will flow upwards. But here this twist here, the wires are twisted, the coil loop is twisted here. This changes the direction of flow of current through the load. Okay, this changes the direction of flow of current through the load. Again, see here, coil side AB towards the north pole, direction of flow of current upwards. This is the closed path from B to A to D, C, D to C, C to through the load, and then again. But here, when the coil rotates by 180 degrees, okay, these wires here are twisted. Now, no matter which coil side is there, a particular coil side, when it is towards the north pole, the current flow will be in this direction. When a coil side is towards the south pole, the current flow will be downwards. North pole, current flow upwards, south pole, current flow downwards. So because of this twist here, the coils are twisted, the direction of flow of current through the load is reversed. Here it is in this direction from right to left, here it is in this direction from left to right. So the polarity of the output voltage is changed. This is this EMF variation, alternating voltage. Now a question might be popping up in your head is that this is a DC generator. We are discussing DC simple loop generator, but here we are getting AC. So here the commutator, which is a very important part of an electrical machine, especially for DC machines, the role of commutator comes into play. We will discuss that in the next video. So here you understand this is the functioning of the simple loop generator. We have a coil placed in a magnetic field. This is the direction of the flux lines. Now the current flow is in this way. When a particular coil side is towards the north pole side, the direction of current will be upwards. The coil side which is towards the south pole side, the direction of current flow will be downwards. When the coil rotates, it takes these positions 1, 2, 3, 4, 5, 6, 7, 8. These points are in pairs. They exist in pairs 1, 5, 2, 6, 3, 7, 4, 8. At each of these points, the magnitude of the EMF will be same, sign, direction will be opposite. Why that happens? Because of this. When the coil is in this position, AB towards north, CD towards south, current flow direction this way, current flows through the load in this direction from right to left. When the coil rotates, the wires are twisted. As a result of that, the direction of current flow through the load is reversed. The direction of flow of current through the coil stays the same in both the cases. The direction of flow through this coil ABCD stays the same. The coil side which is towards the north pole has an upward flowing current. The coil side which is towards the south pole has a downward flowing current. Same thing, because the coil side which faces north pole will have the same direction of flow of current. So the direction of flow of current through the coil side, depending on north and south pole, it is maintained. Only because of the rotation of the coil 180 degree, the wires are twisted here. The wires are twisted. Here there is no twist. When it undergoes 180 degree rotation, the wires are twisted here. Because of that, the flow of current through the load is changed, it is reversed. So because of that we get this alternating voltage. Now in order to convert this AC into DC, we have to use commutators. Now we will discuss commutators in the next video. Okay, so I hope you understood this concept well, and please you watch the previous videos also so that you have a good understanding on these things. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.